exciting it was to, how exciting it was to, implement the first, the first case study, as we call it. And just for everyone's information, this meeting is being recorded, and if anyone wants it later on, we can always give it to them. Over to you, Nivriti.
Okay, so very good morning, Arunima, PJN, and Professor Chandra. I'm very excited that all three of us have come together, and others representing industry, government, and academia, because the nature of this problem is so huge, and there are very many components and areas to be solved that we needed to come together. And having said that, each one of us, I love this name of this project, Raste, because each one of us, especially in India, are on the Raste for 2 to 3 hours each day. We are putting ourselves into danger because, unfortunately, each hour India sees 17 deaths, and we do not want to be one of those 17. Each one that whose life is lost is unfortunately a young Indian, and what worries me is not only is the person whose life is lost, his family suffers, India suffers, and everybody from the world perspective sees a loss. So huge problem, and we've come together and leveraged a technology, artificial intelligence technology, and working towards creating a solution which addresses 3 problems. 1, reduces the collision by as much as 50% that you saw by 2025. 2, not only is it looking at collision avoidance to save lives of the people, what are the factors that cause this accident to happen? One of them is infrastructure. So it looks at what is called the black zone, where the accident has already happened, and gray zone where accident could happen. So it builds a wonderful map of grays and blacks and white zones that can then, the step number 3, be enabled to be worked on. A lot of engineering then can be done on why is this area a gray zone? What can be done? Can there be a learning? So 3 outcomes for this really large problem. All 3 of us, industry, academia, and government have come together to address this problem. And I'm very excited that we have tremendous amount of support from the Minister Nitin Gadkari, his office, and the municipal corporation of Nagpur. And it is first going to be implemented in Nagpur, which is the heart of India, literally and figuratively. As the heart has many veins going up and down, Nagpur has tremendous number of highways, large highways, roads crossing through the city. It's a wonderful implementation opportunity for us. And then our goal is much bigger, to drive this reduction for the country. So that's what I wanted to say.
Thank you,
Arunima, over to you.
Yeah, thank you. And I will now request Professor Narayanan to say something about the project, how the collaboration happened, because there are so many partners in this entire project. The government, it's actually a PPP example. So could you tell us something about the project?
Thanks, Arunima, and good morning to all of you, Professor Chandra, Nivriti, as well as all the journalists from multiple organizations that have joined us. So this is a very exciting project. As academicians, we tend to look at problems in an academic way, but here this is a problem, as Nivriti very rightly explained. It's an easy problem for everybody to understand. Accidents happen, deaths happen, or even worse, sometimes permanent damage to individuals happen, and that's a huge loss for individuals, families, society as a whole. How do you reduce this? The problem is very easy to explain, but not as easy to solve. There are components, we have had sensors and other components to look at the vehicle, the driver, and the situation, and respond or warn the driver, or in advance tell the municipal authorities that something needs to be done here. So there are all these components, the predictive power of AI. So we have been working with, we have I'm representing IIIT Hyderabad and IIITH, which is one of our centers. IIIT's purpose is applying AI to population scale problems, not just problems that help one or two few people in the lab, but at the societal level. And we have been working with Intel as a partner and various government other agencies for the last 3-4 years in the transportation related area. We at IIIT, we released this data set, which is known as the Indian Driving Data Set, or IDD. This is about how the Indian roads are. Just put a camera on and few sensors on a regular car and drive around and collect data and put it up for researchers to use. This autonomous driving or driving assistance has been a very high, very, very active area of research for the last 10 years. And you get all kinds of data and information from all the Western roads, but probably none from India. So we've put out our IDD data set about 3-4 years ago, the initial set, and it's growing every day. Data is collected mostly in Hyderabad and Bangalore, and there are some of them are cleaned up, annotated, and etc., so that researchers can find real value in it. And this later we wanted to take it to the next level of bringing it to the society in the population scale application. And that's when this idea of actual reduction of accidents in a particular city condition, real life situation came about. And I think this is a very challenging problem, and you really see the team that is required. I mean, this is not for IIIT as an education institution to do by itself. We have technology partners, industry like Intel, who can provide a lot of their expertise. We can provide the AI expertise, but none of this is enough. I mean, this is about roads. How do you we don't understand roads the way an institution like CRRI and its scientists understand, because they dedicate their lives to road safety and related things. So we need technically we need expertise of all these, but we also need government such as the Nagpur Municipal Corporation. We can have the best system, but it has to work. It has to fit into their scheme of things, right? I mean, you cannot just say experiment anything on the road, because they need to face the everyday citizen. And then, of course, high-level blessings from government, from the transportation department. Transportation is a concurrent subject, so we had great response great support from the union government and the state government. In Nagpur, we saw all that, and the work has already started. A few 30 or odd vehicles have been fitted with some sensors, and we already have some data that's being processed. But in the next 2 years, we'll see a lot more of it. And we are talking to other government, namely Telangana government is very interested in doing some of it. We are still defining what we can do for them, etc. So I think this is a dream come true for academics. We can do our theoretical or academic research, publish papers, but there's nothing more satisfying than taking it to the field and seeing its impact, especially with such a definite goal that anybody can understand, like 50% reduction in accidents or fatality. So I'm looking forward to the outcome of this project. Back to you, Arunima.
Thank you, Professor. I'll invite Professor Satish Chandra to say how, what was your experience about working with, both academia and with the corporate, and, coming up with such a fantastic solution.
Thank you. Very well said by Professor Narayan and Ms. Nivriti Roy about this problem. And actually, we do not call it accident, because accident can happen in your lawn also. It can happen in your bathroom also. So United Nations now says, whatever happens on the road, it is not the accident, it is crash. So it is basically road crash we are addressing through this project. And this problem is serious because we are in the world, we have largest number of fatalities on our roads, 148,000 per annum. And it is not 148,000 persons who are killed. It is basically 148,000 families who suffer from this trauma. And the problem is complex because it involves the vehicle, it involves the road, and it involves a driver. And driver is the most complex component to understand. And in this project, we are trying to address all three. And that is why if you look at that video which was run here, it is safe system approach. Now, safe system approach basically means addressing all three components: the driver, the road, and the vehicle. So what improvement can be made in the vehicle so that driver is alerted, and how the driver behavior changes with the technology, and how, even if you see the historically, the first accident which was recorded was in 1869 in the state of Ohio. And that accident occurred when the single car was moving on the road and the driver hit the vehicle to the lamppost. So we cannot say that we can bring accident or road crashes to zero. And it is a very moderate target fixed by the ministry that by 2030 we'll bring it to, not 2025, we'll bring it to 50%. So accident can be because of several reasons. It can be vehicular, it can be flat tire, it can be problem in the geometry. But if it occurs, if at all it occurs, it should not be fatal. That should be the target of the technology, that should be target of design, and that should be target of the driver training. So it involves basically all three components, and I'm very hopeful that we will be able to achieve 50% target in next three years as envisaged in the project. And once we are successful, we'll be able to emulate this model to other cities also. And maybe in next 3 to 5 years, we will have more number of cities included in this project IIITH when we go and when we progress further. Thank you.
Thank you. Thank you, Professor. Now, now I'm opening the floor for questions. So please go ahead and ask questions. There are just two requests. If you can, introduce yourself when you're asking the question, and if you can put on your video, that will be great.
Arunima, this is Kurmanad from Business Line.
Yes.
Yeah, if Varma or Narayanan can talk about how actually this happens, the technology behind the reducing accidents or crashes, as Professor Satish was saying, how actually it's done.
How it is done?
Yeah. So your question is directed at Professor Satish Chandra?
Yes. Yeah.
Okay. Yeah. Oh.
So you mean to say you are asking that how you are going to address in this project?
Yeah, actually, how technology is working in the background to stop, instead of saying technology is helping.
Yes.
If you can help, how actually it is modeled to stop the accidents.
The basic philosophy. Basic philosophy here is that if you can alert driver just few seconds before, maybe 2 seconds before a probable collision, then he can take the corrective measure, he can apply the brake, he can swerve the vehicle so that he can avoid the accident. That is the basic philosophy. So when we basically say technology, we are using technology to alert the driver that there is likelihood of an accident or a collision from the rear side or from the side, left side or right side, and he can take necessary action in that. That is the basic philosophy, and that is the premise of all collision avoidance systems, we say CAS, throughout the world, that you should be able to inform the drivers of probable danger.
So Professor Satish, if I can add,
please.
So our solution comprises of using a technology, AI technology, and cameras, front-facing cameras. And by the way, we've done a lot of design engineering to make this solution fit to the needs of India. And you can think of, we have all these cameras front-facing. These are additional pair of eyes. All this data is captured real time, and AI analysis is done, which then generates warnings / alerts to the driver. And we've seen an analysis worldwide, including India and China, where a driver needs at least 2 seconds. That gives him or her enough time to veer away the car from the dangerous situation. So all of these cameras and solutions that we have put together basically generates data that is leveraged by AI-based technologies. And then the technology generates these warnings that the driver can then take action on.
Yeah, thanks, Nivriti, for the clarification. How is Intel involved in this? You have a role there?
Yes, so the technology is provided by Intel, and a lot of AI algorithms and customization is provided by PJN, and a lot of understanding of the data and translating into what it can do for the infrastructure, for the design engineering is provided by Professor Satish. So like he very aptly said, when you look at the solution, there's a car, there's a driver, there are roads, and then there is your technology or instrument that is leveraged. All of this together is basically providing this 50% reduction in what Professor Chandra really called crashes rather than accidents.
So, Nivriti, maybe you should mention that it's just getting deployed in the Mahindra SUV as well.
Oh yes, I completely forgot. Vehicle is a big part of it, and XUV 800 is deploying this solution, and Mahindra is playing a very, very critical role, not just with the vehicular understanding and enabling of this device, but also the good work that they have done in the Nagpur Mumbai highway for road safety. So each one of us is playing our part. PJN also very aptly put, there is a role for AI analytics and understanding, because remember there's 3 outcomes: crash avoidance by 50%. Then how can we identify the gray white zone? So not just know where the accidents already happened, but how can we protect people from poor infrastructure for collisions do not happen? Those are called grays. And then the design engineering. Minister Sir Nitin Gadkari also added, once you have all of this data, how can we learn for better road engineering, for better vehicle,
Please.
represented through the 3 of us.
Good morning. This is Ravi Kumar from the Hindu. Am I audible?
Yes, go ahead, please.
Yeah. My questions are, I have 2 questions. One, is there a time frame in terms of implementation of this project? And number 2, are there devices to be installed in the vehicles? As in, will all the vehicles be covered as part of the project, or will certain vehicles be included in the first phase?
PJN, you want to take it because you kind of called it out in your opening speech?
Yeah, this project right now, this IIITH, we have targeted 2 years for the 50% reduction. But this is a large problem. This project is not going to end after 2 years. We will have enough learning, enough experience to tweak it to the needs as time goes by. And regarding sensors, yes, right now we are focusing on public utility vehicles like buses in the city buses and so on. I mean, these are we are already running a few pilots where 30 or 35 buses have been fitted with the cameras and a few equipment, and it's running around, it's collecting data, and so that we can understand what is the environment in which these buses and their drivers live every day. I mean, there are how these buses these bus drivers, this public transport, especially bus drivers, are tremendously talented lot on one hand. The way they go about in the traffic is amazing. At the same time, you also see them being very aggressive, or we have all kinds of our own observations about them. But so this is a start. In the end, what this process involves, it was explained before, there is the driver, there is the vehicle, there is the road. We need to get information about all three, with advanced sensors, which are expensive sensors mounted on a few vehicles that go around, can get a lot of information about the roads and how things happen there. Individual vehicles, if you are going down to passenger cars or even two-wheelers, they are very important in this equation. We cannot have very expensive equipment mounted on each of them. So the part of the research is what is required, what can give most bang for the buck, most benefit for the investment involved there. So these are all part of the study as we go forward. There are many advanced collision detection kind of hardware sensors that exist from different companies in the world. We may have to, we will experiment with all that. We already started work on some of them, but we will also see how we can develop our own, because India is an extremely cost-conscious economy. If you cannot say a car that costs 5 lakhs, you put 1 lakh worth of equipment on it. It's just not going to fly, right? Maybe 1%, maybe 2% of the cost can be added for the eventual benefit, not more than that. So this is all part of the whole effort of road safety for the future.
Yeah, if I may add just one thing, as Professor PGN already said, right? 30 buses. Eventually, we are planning to equip up to 350 buses, right? The Nagpur Municipal Corporation fleet, and we might go beyond that, but that's the minimum we're planning to do as part of this.
Just to get a clarification on this, when we talk about buses being part of the trial run now, are we talking about a project where we are trying to get data first and then we will come up with some solution later, is it?
So let me answer that, and PGN, you can please expand over it. So we have been collecting data, PGN mentioned, India driving data set. And this has been going on for the last, I would say more than 2 years. It's almost 3 years. Not only that, we've conducted proof of concept trials in 4 different states. We've done it in Karnataka, Telangana, Kerala, and UP. So a lot of this early investigation, data collection, proof of concept has been done. Now we are implementing the solution that we have built over the last so many years, with customization required for India. Like PGN was saying, India needs are very different, not just from cost perspective, but even from design perspective. We are not using LiDARs, we are not using radars, but we're using cameras. However, there are a lot of other design innovations that have went in through all of these partners that we talked about. And it's an implementation. Post Nagpur, the goal is to implement it for the country. PGN, would you like to add, please?
Yeah, so I think all of this is part, what you said about data collection is definitely a part of it, because without data and without understanding the on the ground situation, we cannot do anything. And fortunately, today's the expansion or revolution in the IT and sensors, we have the ability to collect large amounts of data. And this is, by employing a very inexpensive techniques. Like just now, we have a car on our campus, which is we fitted with not very, very expensive sensors, but it's not, it's not 1,000 rupees or 5,000 rupees sensors, little bit moderate budget sensor. And this car goes around, say, Hyderabad roads and collects information about the roads. Where are the water logging happening? Where are the, the lane markings available, not there? Where are the traffic signs which are, that are clearly visible or not visible? Very simple data. It may look very simple, but this kind of information will be the basis of recommendation we make to the GHMC or the municipal commissioner, and actions we take to the drivers. So to compare with this, the autonomous driving effort that has been taken the fancy of many people, including Google, they have instrumented, or at least mapped out the entire every inch of roads where the vehicles can drive. Where is the stop sign? How high is it? What is the color of the stop sign? The stop signs are red, orange, and green, but not all reds are same, not all yellows are same because of the physical light, the bulb there. They map out all these things because they are aiming at fully autonomous driving and so on. So that's the huge amount of data is required if you want to go that level. While that may remain a dream for all of us, especially in the Indian context, what can we do in the immediate need? So there will be data collection, but we have already started. So maybe Professor Satish Chandra can answer better. The data that came in from the buses in Nagpur, we've already correlating it with analysis done by experts like CRRI, and I think maybe he can summarize. I'll leave it to him for the rest.
Professor Chandra?
Yeah, Dr. Melmurugan is here in this
Please add.
meeting. I think he can better explain what data they have collected so far and what is their,
Yeah, thank you. See, basically, as was requested, we have collected about 30 buses right now, and we plan to collect 350 more buses. But what I want to tell here is this particular data, what is being collected through the buses, these buses are expected to run through the entire length and breadth of the Nagpur city. So because the routes, the entire routes are going to cover the entire, so that way, with the three-pronged, the three vectors, vehicle safety, infra safety, as well as your mobility safety, we are going to address it, because when the bus is going to run through the entire city, wherever the gray spots are possibly there, that will be taken on board, which is going to interact with other vehicles in the traffic stream. That is so that way the concerns of other road users, like vulnerable road user, like a pedestrian, or the worst lot, and to the other forms of vehicles like cars, two-wheelers, other trucks, everybody's concerns will be addressed when the bus is going to run through the length and breadth of the city. So that is the gray spot what Ms. Nivriti Rai has spoken about. And thirdly, the infra safety, what we are telling, there are identified 52 locations are there in the city as per the MORTH protocol. That is confirming to 5 road crashes at 10 deaths have happened during the last 3 calendar years. That data has been taken on board. Based on that, the existing locations will be fully addressed to by giving the holistic engineering solutions. So that way the 3 vectors will get covered. So we hope by 2023, August 23, we expect if these all these data gets processed as well as the measures gets implemented, there is a possibility of 50% reduction in deaths and crashes. Thank you.
Any more questions?
I have 2 questions. Can I go ahead?
Yeah, please.
Hi. First, I wanted to understand that, this project that you're doing, is it going to run for a specific time frame wherein you collect data and share it with the government? Is that how it's going to work? If that's the thing, what is the time period? And second, there's already a lot of data available on road conditions. There's real-time data coming in, people on social media sharing details about potholes, and Delhi recently had like massive rain and flooding that happened at certain points. Is there a mechanism where you take in this data into consideration as well? Because these 30 buses or 40 buses could be at specific points in time, not covering and not be present within the city at the points where there is actually congestion. So do you take into consideration this real-time data as well? Thank you.
Again, you want to take it? I can start, or Varma, why don't you take it?
Yeah. Let me add a few things and then.
Yeah, and then I can add.
Yeah. Stuti, the first one was about the duration.
Yes.
Yeah, the duration is 2 years, Stuti, right? But like as Professor Vijayan mentioned, 2 years is the current duration, but we'll definitely have a lot of learnings where we'll do more. But our targets right now are to accomplish this, up to 50% reduction in accidents and fatalities in 2 years, right? That's the thing. Second one, actually at IIIT and IIIT, we have a lot of other projects where we have put simple cameras on two-wheelers and other things, right? So we are evolving mechanisms to use crowdsourcing, right? But that's not part of this project, but that's something we definitely look at so that we can have much bigger set of sensors that we can get data from.
If I may add, a lot of data that is already there, definitely we want to leverage. I want to just highlight in his speech that our Honorable Minister, Mr. Gadkari gave yesterday. He clearly called out that police has a data repository. Nagpur Municipal Corporation has a data repository. Many of the institutions have a lot of data. But know that there is no standardization based on which this data was collected. Now, AI works wonderfully on data. So firstly, we have to remove noise from the data. Secondly, it has to be a standard that the AI algorithms can read. So yes, definitely, the more the data, the better the AI algorithms perform. And like Varma very nicely mentioned, crowdsourcing. So like, Mr. Velmurugan also mentioned, we are looking at crowdsourcing information real time, as well as leveraging the data that's already existed, but know that it needs to have a standard and it needs to be devoid of the noise. There is a lot of things, the way we call it a signal to noise ratio. The good data is there and then a lot of noise is there. That needs to be removed, and then this data needs to be put in a certain standard so my algorithms can read. But answer, yes, absolutely. PJN?
Yeah, so we need to use all the data that is available, obviously, because these are going to take a lot of time to collect this data. At the same time, I'm not sure road conditions, potholes, water logging, there is a systematic way of collecting the data for most cities. And this is, in fact, that is one of the things that we have been proposed to the GHMC in Hyderabad, that our car driving around and collecting data can tell GHMC that, here there is a problem. We are seeing this very simple analysis, water logging after rains, or, potholes or damage to the roadsides or road signs. These are very dynamic data. What happens today is not what may be there tomorrow. So collecting data is an ongoing process, and all analysis and conclusion will depend on this data. So it's a huge effort, but we are very excited because a lot can come out of this data.
Yeah, I'll just add one more thing. Beyond road data, one important piece of data is actually the nature of the accidents and how they're happening. Here, actually, the DCP traffic and the traffic department in NMC has been very helpful. We actually got all the data, all the FIRs from the past 3 years. And we're doing a very systemic analysis of that entire thing and put it in a very structured format, right? That will give us a lot of insights. That has not been done anywhere so far, because they do the FIRs and they do their thing and then they move on, right? Nobody has looked at that entire corpus of data, right? So that will add a new dimension to this as
well. Good morning, everyone. I'm Swati. Am I audible?
Yes, please go ahead.
Okay, what I wanted to ask is, you mentioned earlier that you have been conducting pilots in other states as well, in Kerala, UP, Karnataka, and Telangana. So if you can also explain a bit that, did you also have those anti-collision devices over there, or it was just about collecting data? So what kind of work you've done there, and how is it going to help you in what you're doing in Nagpur right now?
So we absolutely had the anti-collision devices, and we absolutely had the data collection in process. And I'm happy to tell you, out of these trials, we saw 40 to 75% collision reduction or crash reductions that we saw. Now you'll say, why this wide variation? Wide variation because it was a lot of function of, some of the states where infrastructure was already much better, we saw lesser improvement. Where, the infrastructure was poor, there we saw, 75% of reduction. So yes, we've already tested it. We've seen our algorithms perform where crash reductions are seen, and a lot of data that was collected. PJN, his IIIT Hyderabad, the Institute IIITH has worked on that data to update some of the algorithms, to update a lot of design of this entire solution that we are implementing in Nagpur. So yes, a lot of learning from there has been implemented, but dynamic data collection is required because that's how the algorithm works for even collision avoidance, crash avoidance.
Yeah, the one big difference I want to add is most of those pilots that were done in Kerala, Karnataka, and Telangana are smaller ones, right? 20, 30 vehicles. Now, the big difference is the scale at which we're doing in Nagpur, right?
That's why we don't want to call this a proof of concept or a pilot. This is actually a deployment in the city of Nagpur.
And also, if you can explain for a layperson, how did this device look and what was the cost of it and who was actually installing it?
Let me take a stab and then Varma, you can add on.
Sure.
So this is a solution that has, cameras, devices, ability for connectivity, all of that. And who's installing it? We have people who have expertise who are actually installing it in different vehicles. And I forgot what was the third question. The cost. I can assure you, while a lot of work that IIIT Hyderabad, IIITH, and Intel and all our partners have done, we have optimized this solution to work best for India. We are also working at improving it such that the cost is the most optimal without losing its efficiency. So like PJN said, do we have LiDARs? No, LiDARs are very, very expensive. Do we have alternates where instead of LiDARs, we have solutions that give us the same outcome, but at much lower cost? Answer is yes, we are doing that. And that is what, the design engineering is enabling us to do. There's no way, India has 1% vehicles of the world and 11% accidents. So you can see, there is a order of magnitude difference, but the affordability is less while the life is equally precious. So what we are trying to do is save the precious lives within the affordability that our country has. That's why all of us, whether it is CRRI, whether it is IIIT Hyderabad, IIITH, Intel, and Mahindra are coming together to work with Municipal Corporation of Nagpur to just do exactly that. What is the data that we saw in India? How can we get the same amount of accuracy and efficiency with more affordable solution? And that's what we have worked on and trying to implement in Nagpur. What the cost is, we're still optimizing, and once we believe that this is a cost that is ready, we will definitely share.
Just few points, right? So we have a small team, implementation team that's actually installing, right? So the 30 vehicles that are already the NMC fleet, right, we installed, and we're continuing to do more up to 350. The actual device has two small components. There is a front-facing camera that is looking at the road, that's on the dashboard of the bus, and there is a small watch size, right, wristwatch size indicator that gives a visual and an audio indicator to the driver. So maybe after this, we'll also send a picture of that also, Swati, so you can see that.
It's a tiny device on the, and it doesn't require re-engineering the car or something at this stage. All it needs is power, nothing more at this stage.
Correct.
So we're looking for a disruption, guys, a disruption worthy for India, innovative disruption.
Any more questions?
Yeah, Arunima Ravi Kumar again from the Hindu.
Yes, please.
There are already so many cameras installed by traffic police. I'm sure that's the situation in Nagpur as well. Will feed from those cameras also be used as part of this project? And My next question is, in India, many of the accidents actually are too small to be registered per se, because and often they get into compromise and they go without filing a police FIR. How do you take that into consideration?
So maybe I can start and Verma, you can add.
Yeah.
So like I said before, any data that can enhance the accuracy of AI, we would love to adopt. Are we already doing it? No. Like I said, there needs to be a standard and there needs to be a data cleanup. After that, PJN would love to incorporate that data into his, analysis, and I'm sure Professor Chandra would love it. Now, you talked about, there are many accidents that were not registered, they were too small, etc. So our algorithm is not built on the accidents that already happened, but the black zone that we talked about, that is coming from an accident already happened that perhaps needs to be registered. But what the strength of our solution is the gray zone mapping. That is a predictive capability which says, oh, this XY location, it's not just the potholes. Let me just give you one example. This XY location, the road is turning, but there's not enough banking in the road. Banking means that, you need to make sure that there is a certain angle to the road curvature, so your car doesn't, swerve off. So gray zone mapping is a predictive capability to avoid accidents, is the strength that, this solution brings. Forward-looking accidents should not happen, but the black zone is a function of knowledge of where accidents have already happened. They may be missing those accidents that were perhaps not registered, but will that impact us, our gray zone? No. Verma and PJN, you want to add?
You're muted, Verma.
Yeah, sorry, I'm muted, right? Yeah, our registered accident itself, we are the highest in the world, right? So yeah, there are a lot of unregistered as well, right? So that will be the case anyway, right? Our solution, right, tries to reduce the behavioral change, just to reduce any accident, registered, unregistered, right? So just based on the numbers we have on the record, if we can reduce that, the unofficial numbers also will come down, right? So that just goes with the way things are.
And about this, Dr. Velmurugan already written on the chat saying, these cameras on the traffic lights, etc., are definitely useful, but they are static. They cannot provide, he has written, they did not provide for mobility safety analysis, but they may have their role if they, if you can get data about the whole intersection, junction, what is happening, etc.
Thank you very much.
So, can we conclude here? Any more questions? Okay, thank you, everybody. Over to you, Verma, if you want to have some closing remarks.
Yeah, I think we're almost getting there, right? 11:30. Let's wrap up. First of all, thank you everybody for making the time to attend this event. Right? Working on AI and all the new stuff that is coming along, and publishing papers and doing all the stuff is one thing. But the key thing with this project is combining all these things, right? The developments in AI and actual road engineering that the engineers at CRRI do on a daily basis, right? And bringing this technology, the ADAS technology that we have, bringing all this together and trying to meld all these things into something together and make an actual difference, right? At IIIT, we have two major focus areas. One is smart mobility, the other one is health. In both these things, we take up projects to make an actual difference on the ground, right? So this is it's a big project for us, right? So we hope to do that over the next 2 years and then replicate it in other cities in India as well.
Thank you. Thank you all very much. We'll make the next announcement when the next state, decides to implement this project. We are just looking forward to more and more states, adopting a safe travel on the road. Thank you all.
Thank you. Thank you all. Thank you all for joining.
Thank you, everybody. Bye.
Thank you very much.